Module 18.2 Day 2 Sine and Cosine Ratio. Content Standard. Understand that by similarity, side ratio in right triangles are properties of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. Language objective. Explain to a partner how to find the sine and cosine of an angle given a diagram of a right triangle with given angle measures and opposite or adjacent leg and opposite sides. Right. Finding side lengths using sine and cosine. You can use sine and cosine to solve real-world problems. Example 3. A 12-foot ramp is installed alongside some steps to provide wheelchair access to a library. The ramp makes an angle of 11 degrees with the ground. Find each dimension to the nearest tenth of a foot. So here we're observing from this angle. So we know that this is opposite and this is our adjacent and that the hypotenuse. So we're solving for x, so then we're looking at opposite and hypotenuse, so we use sine. Okay, so let's go overview what we did from yesterday. Right? So you see that if sine of an angle is equal to opposite over hypotenuse, and cosine of an angle is equal to adjacent over hypotenuse. Right, so we're solving for x, so we have opposite and hypotenuse, so we said sines of 11 degrees is equal to opposite, which is the wall, over 12. So to solve for the wall, so the wall equal to 12 times sines of 11 degrees. And from there, just use your calculator. So this is 2.2897, and this is in terms of feet. Okay, let's go to example B. Said find the distance y. So if we're looking at the same triangle, so then we're observing from this angle, so this is adjacent and hypotenuse. So we can use cosine. So we said cosines of 11 degrees is equal to adjacent AB over the hypotenuse is 12, so then AB equal to 12 times cosines of 11. Make that a 11 degree. So from there, just use your calculator. So then this 11.7795 feet. Okay, and for number 10 said, could you find the height of a wall using cosine? Yes. Remember that we have learned that sines of 11 degrees is the same as cosines of 90 degrees minus 11 degrees. So then this is 90 minus 11. So there will be cosines of 79 degrees. Okay, so let's try number 11. Suppose a new regulation states that the maximum angle of a ramp for wheelchair is 8 degrees. At least, how long must the new ramp be? Round to the nearest tenth of a foot. So we're looking for this part. Okay, and we're given that's the wall. So we have adjacent and opposite. Oh, then for this one, we need to go back to our 18.1. Remember that when we have opposite and okay, my mistake. We're not looking for the we're looking for the ramp. So then we have opposite and hypotenuse, so we can use sine. So we do sines of 8 degree equal to opposite, which is 2.3 over the ramp. So then that means that z is equal to 2.3 over sines of 8 degree. From there, just use your calculator. So 2.3 over sines of 8 degree. So this gives us 16.526. Okay, so then z equal to 16.526 feet. Okay, so let's go on to this one. Find the angle measured using sine and cosine. Okay, so we have learned from day one to find the angle, we need to use the sine and cosine inverse. So let's say if we are observing from angle A, so we have opposite and hypotenuse. So then we can say that sine of angle A is equal to 5 over 10, which reduced to 1/2. So then that means that the measurement of angle A is equal to sine inverse of 1/2. And from there, to use sine inverse, you need to do shift on your calculator. So do second or shift sine inverse of 1/2. So this gives us 30 degree. Right? Okay, and we see that angle A and angle C are complementary, so they're 90 degrees. So if A is 30 degree already, that means that the measured angle C must be 60 degree. Right. Okay, so for example 4, find the acute angle measure of PQR to the nearest degree. Right. So here we're looking for angle R. So we're observing from angle R. So we have opposite and hypotenuse, which means that we have to use sine. So then we get sine of angle R is equal to 7 over 13. That means that the measurement of angle R is equal to sine inverse of 7 over 13. Okay. So this gives us 32.56 degree. So that means that the measurement of angle P equal to 90 minus 32.56 degree. So it would be 57.44 degree. Right? Okay, so this take care of our question B as well. Right? So write and evaluate the inverse trigonometric ratio to find the measurement angle R and angle P. Okay, for number 12. Okay, how else could you have determined the measurement of angle P? Well, if we go back to our drawing, we have this R, Q, and P. This is 7 and 13. Well, if we are observing from P, then we have adjacent and hypotenuse. So we can use cosine of angle P is equal to 7 over 13. So then the measurement of angle P equal to cosine inverse of 7 over 13. Okay, let's go on to your turn. Find the acute angle measure in triangle XYZ to the nearest degree. So try these two out in a minute. I'll give you the answers. Okay, so we're observing from y, so we have adjacent and hypotenuse. So we use cosine. So you do cosines of angle y is equal to adjacent over hypotenuse. Okay, so which means that the measurement of angle y is equal to cosine inverse of 14 over 23. So this gives us 52.5 degrees. Right? So to solve for z, we can do two way. So then we say that then these two are complementary. So we can say that angle z equal to 90 degree minus 52.5. So then this gives us 37.5 degree, right? Or you can solve for z by looking at z. So we're looking at z that opposite and hypotenuse. So you can say sines of angle z is equal to 14 over 23, and so to measure angle z equal to sine inverse of 14 over 23, which will give you these same answers. Right? Okay, so let's try these. Use sine and cosine ratio to solve problems 11 through 13. So for number 1, to the nearest, find the perimeter of the triangle, round to the nearest 0.1 centimeters. Right? So that means that we need to solve for, let's call this x and call this y. Right? So we're observing from this angle. So to solve for x, we say that we have opposite and hypotenuse. We can say sine of 18 degree is equal to x over 4.2. So that means that x equal to 4.2 times sine of 18 degree. Okay, so let's use our calculator for that. So 4.2 times sine of 18 degrees. So then x is given as 1.29. So we can round this up to 1.3. And to solve for y, well, this is your adjacent and hypotenuse. So we use cosine of 18 degree equal to y over 4.2. So then y equal to, so then we have 4.2 times cosine of 18 degrees. So then y is roughly 4. So then to find we're looking for the perimeter, so it will be 4 plus 1.3 plus 4.2. So then the perimeter is 9.5, and this is in terms of centimeters. Right? Okay, and for number 12, to the nearest 0.1 inches, what is the length of the hypotenuse of the springboard shown to the right? So we're observing from this angle, so then we have opposite. And here we have the adjacent and hypotenuse. Right? So we're looking for the hypotenuse, we're looking for this part. So we have adjacent hypotenuse, so we need to use cosines. We do cosines of 16 degree equal to 35 over the hypotenuse. So that means that the hypotenuse equal to 35 over cosines of 16 degrees. So 35 over cosines of 16. So this gives us 36.41. Okay, so then in terms of inches. Right, okay, let's go on to number 13. What is the height of the springboard? So we're looking for the height here. Right? Well, we can use what we learned from 18.1. So we have opposite and adjacent. So then we can use tangent. Right? So you can do tangent of 16 degree is equal to the opposite, so call it the height, over the adjacent, which is 35. So then the height is 35 times tangent of 16 degree. Okay, so then the height is, let me write it here, is 10.036, or we can round it to the height is equal to 10 inches. Okay, so that's the end of our 18.2 day 2, and your assignment is to work on number 9 through 16 in your book, and to finish and turn in your HRW, also copy down 18.3 day 1 notes,